Our universe has a number of great mysteries that continue to baffle us to this day. It was once considered that humans experienced the entire cosmos as ordinary matter and energy. The ancient Greeks even understood the concept of the atom, but they had no idea what caused other things to happen. Imagine their surprise now, when we have harnessed the might of the electron from their notion of lightning bolts as godly weapons. But as our understanding of the universe grew, we discovered that there were abnormal forms of matter and energy such as antimatter which we can now create but didn't have much of a concept of until Paul Dirac proposed it in 1928, though some abandoned theories that predated that had something resembling an antimatter concept. Hello everyone, welcome back to Zeey. In this video we will try to see the strange case of double Big Bang. Subscribe to the channel and follow us. In its true context, it is opposing matter with flipped charges that annihilates when it comes into touch with normal matter in a tremendous explosion of energy. Misbehaving galaxies were another clue of some kind of other stuff. We discovered that galaxies should fly apart since the matter we observe in them lacks the mass to hold the state of affairs together, leading to a number of hypotheses about what was causing the gravity. After accounting for all regular matter in those galaxies, nothing tallied up, not even close, implying the existence of dark matter, a substance that interacts with everything gravitationally but not in any other easily detectable way. Interestingly, it's possible that this theory is incorrect or situational in some way, as there have been hints of galaxies with no dark matter, which is a known issue. As a result, dark matter behaves strangely, passing easily through barriers and effectively acting like a ghost, although this is not unheard of as a particle whose nature we do know. The neutrino also does this. They can flow through entire planets without interacting, although they can occasionally make a direct strike on another particle and be discovered, albeit with a high degree of chance and difficulty. However, such searches for dark matter have so far shown no results. Whatever it is, it appears to be distinct from neutrinos in this way. Even further out, but perhaps related, is dark energy, which is speeding the expansion of the universe and may or may not be related to dark matter. As a result, these odd forms of matter and energy throughout the cosmos do not exactly fit with our current understanding of the Big Bang. We still know so little that we have no idea how this situation came to be. But one fresh testable theory we'll probably know the answer to this issue in the next few years could offer an entirely new dimension to the study of the Big Bang. In short, there could have been two of them, going off one after the other, causing two very different outcomes that gave us the universe we have today. The effect of a single large bang and the shadow effect of a second. Fries and Winkley outline the possibility of a later dark Big Bang in addition to the standard one in their study. The current widespread view in cosmology is that the universe entered a period of cosmic inflation a fraction of a second after it began. The cosmos expanded faster than the speed of light here, propelled by vacuum energy and rules that differed from what we know today. This epoch, which lasted less than a second, grew the cosmos from the size of a subatomic particle to the size of a small town. When this happened, the energy that was driving the universe's expansion calmed down or changed form, allowing normal matter to develop. This is the Big Bang, the shift from inflation to a location of enormous density and heat, a gigantic plasma. But where does dark matter fit in? If it's a weakly interacting particle such as a WIMP, it may or may not fit into that mix. Whatever it was, gravitational anomalies indicate that dark matter, which is 5 times more abundant than regular matter, must be the dominating form of matter in the universe. The problem is that its gravitational effects are the only indications of its existence. It appears to interact in no other way. The current working hypothesis is that matter and dark matter were generated at the same time, and that there were stages involved that managed inflation in such a way that matter produced 2 separate outputs. But we don't know if this is accurate. It's only a hunch, and this new paper presents an option. It's possible that matter and dark matter are so unlike that they didn't coexist. The energy of inflation produced conventional matter but not dark matter in this circumstance. It may have been something else. It's possible that two types of energy were engaged. Vacuum energy produces inflation and the development of matter, but it also causes dark vacuum energy, which then results in dark matter and may be related to today's dark energy. However, this is highly speculative and may not be the case. The intriguing point here is that the effects of vacuum energy and dark vacuum energy do not have to be transformed into particles at the same moment. In other words, there may have been no dark matter at all at the very beginning of the universe, for as long as a month after the cosmos began. That may not seem like much for a cosmos 13.8 billion years old, but it is an enormous length of time for Big Bang cosmology. This effectively results in a second, dark Big Bang, where dark matter began condensing from dark vacuum energy long after matter began condensing after inflation. It's unclear if this will be a non-starter of a concept or a discovery that adds an entirely new dimension to the account of how the world began. However, in this instance, the double Big Bang idea can be tested. Current efforts to discover dark matter are all founded on the assumption that it, like the neutrino, may occasionally interact in ways other than gravitationally. This is a bad problem, because if it does not, all dark matter detection experiments will fail. Because of that possibility, we may never be able to solve the question of the nature of dark matter. It would be the particle that we know exists but can never verify, no matter how advanced we get. Similarly, it might represent the unknown to all civilizations in the universe. Permanent unknowables in science are brick walls, and this is a poor outcome. However, if there is such a large gap between the formation of dark matter and regular matter that two massive bangs occur, it is quite possible that there is no interaction between the two other than through gravity. Gravity would be transformed into something quite unique, to say the least. But here's the catch. If it was actually dark vacuum energy transitioning to dark matter particles, the transformation may have left telltale fingerprints, sending shocks through spacetime that may be detected as gravitational waves. This event would then have a possibly detectable background. This is frequently referred to as a cosmic hum, but it's not a particularly good analogy. However, some early investigations appear to indicate this form of hum, albeit much more research is needed because a variety of origins for this type of hum have been advanced from other more commonplace astronomical phenomena. However, when more research is conducted and measurements are obtained, some forms of gravitational wave background may reveal and establish the existence of the second dark Great Bang. On the other hand, it is possible that this research will ultimately bring a breakthrough in understanding dark matter in a new way. We'd not only have the effects of its gravity to study, but we'd also know where it came from, widening our pool of information to the point where we might be able to figure out what it is, especially if it's a weakly interacting particle. Even if we can't directly detect it, these two lines of evidence may help to explain it. One peculiarity here is that we clearly have a bias in this whole process. Despite accounting up only approximately 5% of the universe's mass, we term it normal matter. Dark matter accounts for 27% of the total, with the remainder being dark energy. We are in fact an abnormal form of matter and energy in the cosmos. What happened if there was a second Big Bang, and why is there so much more dark matter? This may reintroduce antimatter into the equation. As far as anyone can tell, the traditional interpretation of the Big Bang should have created equal amounts of matter and antimatter, which should have been utterly annihilated. Something in the cosmos caused an asymmetry here. There was somewhat more matter than antimatter, with a small amount of normal matter remaining. It wouldn't be remarkable if the relics of the Great Annihilation were simply the remnants of the Great Annihilation constituting such a minuscule part of the universe. This may not have occurred in the case of dark matter. Some particles, such as photons, are antiparticles to themselves. It's possible that dark matter isn't charged. In other words, there is no anti-dark matter. On the other hand, normal matter has antiparticles. If the charges of protons and electrons in atoms are flipped from plus to minus or vice versa, they form antimatter. A proton is converted into an antiproton while an electron is converted into a positron. Dark matter may not have this juxtaposition at all and is a good candidate for a particle that is by nature its own antiparticle and thus does not annihilate, implying that it could become the dominant form of matter in a universe set up in this manner, with a fundamental difference between normal matter's particles with charges and non-interactive dark matter particles without charges. One type undergoes annihilation while the other does not, possibly explaining the ratios but leaving the asymmetry of matter and antimatter unresolved. Indeed, we still have a lot to learn about the cosmos. Alright folks, that is all for this video. Thanks for watching. Is there anything you like to say about the double Big Bang theory? Please tell us in the comment section below, and remember to like, share and subscribe to Zeey.